My name is Devrim. I work for Swisscom. We have an office in Rotterdam, Swisscom Rotterdam Center for the last 5 years. And I'm also a member of Telemetry since last year. I can't say I contributed afterwards much, unfortunately. And also in my personal life, I help the Matrix Club in Rotterdam with the live stages and live streams, which we have North Sea Jazz Festival ahead. And we have 9 shows there since the event is in Amsterdam. We welcome you to Matrix Club. It's just half an hour. Okay, about this talk. Actually, 2 years ago, the first time I gave you a talk in SREday about especially the visualization part of the observability. And back then, I put whatever I know on the table and looked for what is models, a search for what are models. And back at the time, right before ChatGPT, at least I was able to spot that the data with the observability we are collecting is spatial temporal data. And mainly my presentation was over predictive models. What changed since then? I happened to come across this model picture in a Santa Fe presentation. And this presentation, balanced philosophical implications, changed the way I look models over 20 years. I look much more flexible. But if you ask me to define what is a model, that description itself will be a model. So it's very recursive. I just found my piece there, and so I'm much more comfortable. And when it's compared to the previous one, I made another talk last year. The things I have put on the table, I was able to put them inside a framework after my piece with models. And which is, I discovered that predictive model is not the only model out there. To be able to explain, understand, and especially to be able to explore what's out there is really important, along with many other models. And I tried to map the CNCF product over a self-organizing complex system as this, so I packed all the cables together. And this talk is kind of a trailer of these two. And the reason of the talk, I don't know whether you started touching agentic AIs, the Copilot agent combo box. How many? Thanks. So I strongly recommend a lot of people to try, because it's one other step since 1.5 months everywhere. When you are working with Copilot, it starts to edit your files automatically. Cloud has a similar technology that's called Task Manager. You give the tasks and the agents start working about it. Codec from OpenAI directly works with GitHub. It makes commit just like a developer. For example, a dependency, what I have put on the left-hand side, the renovate bot, it also creates merge requests towards our pipelines. Software development lifecycle is changed, and pretty much not just DevOps engineers, SREs, we are both excited and frustrated with the situation. And I found the very best definition from, on my point of view, in a very recent presentation that's done by Andrew Karpathy, where he says a huge amount of software will be rewritten. I don't know whether it's going to be us or something else. However, he puts the situation like this. He tweeted 1.5 years ago about software 2.0, which was a debate itself. 1.0 is what we write today with Java or within a YAML file. That's what we put in there. 2.0 is how we train the networks. And once the model is trained, we start an integration between 1 and 2, which is already in many enterprises. We are, from our code, calling LLM APIs and requesting stuff and so forth. 3.0 here is just arrived 1.5 months ago. We are facing with it, really. And that part is mainly about, instead of you writing the code, you make the LLM write that code. And that 3.0 is basically a formation of pro. At one time, pretty much all AI vendors started pushing their own solutions towards here. And this is not something, I'm not on the AI field, I'm on observability field mostly. However, what I see as a raw engineer when I touch these stuff, OpenAI seems to be targeting the end user and especially trying to enhance. GitHub Copilot is fantastic in integrated development environment, and its agentic mode, it's even better. And it's defined as augmented coding. So when you are doing, it's helping. Even it's in agent mode, you are the reviewer. I didn't try directly the Cloud's task manager. However, I used some of the under Copilot. It's really strong. Google has similar stuff like OpenAI. They launched Jules. There are a bunch of 4 or 5 different options there, AI, Google Studio, and so forth. And there is the Cursor AI, Windsurf on the market. They are also doing test management and giving agent-wise things. But on the other hand, with Google's AlphaEvolve new paper, they put out very simple architecture which takes the responsibility directly from coder and puts it into pipeline. And it's basically based on evolutionary algorithms. They didn't advertise it much. There is very less podcast about it, but still I do believe, yes, there is the consumer side, but we are mostly working on enterprises, and we are stricter. We need to look at it on an enterprise angle. And when you think, the picture on the left is from Google's, that's the open source package management dependency graph of a open telemetry Go libraries dependency. On the right-hand side, this is a service graph representation that I prototyped 3 years ago over open telemetry architecture. When it opens, it kind of services starts, and you see it something like under microscope, the service graph, nothing too different than any other service topology map, just the style is different. So when you look at this, when the code sits in a repo, it is static there. It's not alive. When you put it on a run system, it starts to interact with other systems and does some stuff. So it kind of exists in time, and it has relation with its surroundings. Within this sense, like many other complex systems around us, it can evolve. And that's what Google engineers figured out with AlphaEvolve. And when you look at the AlphaEvolve paper, you would see some mathematic expressions of examples, scientific side, but also you will see this. And I do believe these are pretty familiar with you, the CPU memory utilizations. This is one of their evaluators where they let the evolutionary architecture try stuff, and if it reaches better, they take that program. And this is for Kubernetes. If you look at their paper, you would see that they have a 1% for now reduction in their operating cost just by discovering this algorithm. And they applied. So it's not scientific, and it's a very easy ladder for SREs and DevOps engineers to get in to the main line, I would say, trendy line, hipster line. But this is where we really intersect. At this point, I will rush through the architecture itself. Architecture itself is a star architecture. The upper side is from the AlphaEvolve paper. In the bottom, I will try to map the CNCF open source tool to this architecture hypothetically. So here, now I will run through this trade. First of all, what they call in their architecture program database, which is the green one here, is nothing but you can consider it as a commit ID, release ID, the identity of the software itself, some aggregated scores collected from the observability stack. Keep that in mind all the time. There's an observability stack in the backend. As a proof of concept, I will be just saying Grafana LGTM stack for ease of using my proof of concept. And Open Telemetry is pretty much collecting all data from all around. And in the scenario, a DevOps engineer or an SRE enables dependency management software, Renovate, on GitHub. And Renovate bot afterwards, daily, depends on your schedule, check the package dependencies about the software. Here, I didn't use a real developer. I selected Renovate as a robot developer, which would make sense for later. It can be expanded to real developers. Renovate bot discovers on Open Telemetry demo application a gRPC package update for ACP for .NET application that's inside the Open Telemetry demo application, and creates a merge request towards GitHub. That starts the what's called AlphaEvolve's evolutionary loop at this point. And evolutionary loop, what it does, it takes a parent program, which is the version running on the prod for my proof of concept. It also gets some inspirations, which are first predefined and maintained later. But at this point, my inspiration file, sample file I created from using an AI, is pretty much defining a merge request from a dependency package update management software. And so that it's a very simple, not an evolutionary, a couple of cycles process here to keep it simple. So it gets the prod program from the database. What it gets from the database is actually what prod program did before in pipelines, and also what is it doing at the moment in production. So it's a very compressed form of scores that is associated with the software program itself. Here, I'm putting a very simple DB in that sense, and it gets a sample from there, the prod code and the version numbers and its performance values. Then it goes all the way down to prompt sampler part. What prompt sampler does is actually, before you instruct an LLM to write a program, instead you go to another LLM and say that I want to write this, so instruct the other LLM, which is found to be much more performant. And according to this Renovate bot merge request, it provides a context. And within this context, what I need is just a package upgrade. It will test it. However, in the context, I will request also to write some specific tests regarding that update as well to keep the confidence level. So here, this prompt sampler mainly gives a prompt for the ensemble and requests a patch regarding this merge request to test some diff files, and also including some test code instructions and so forth. On this LLM ensemble, they are using it can be any LLM, doesn't matter. They are using one small and one reasoning model, which the small model creates quick, cheap variations of code, but the bigger one then assembles them, and if there is problem back and forth here, it gets better. However, the output is very simple. The output is the number of diff files, where that is the point we are back to our own universe, to Kubernetes. The evaluator pools on their architecture picks up these diffs, deploys them through Argo CD to an ephemeral test environment, Open Telemetry Devo application, which is tailored with the needs of the merge request. You don't have to deploy everything as well. And meanwhile, on parallel, the Argo CD deploys Argo with workflows, ephemeral test containers, where Sonoboy within CNCF supports Gherkin. I never liked Gherkin. I find it very impractical. However, maybe with AI, it is the time for Gherkin. That's why I put it in this hypothetical scenario. And also Open Telemetry demo application as shown in the morning sessions. It's a really full-fledged application. It has load test, trace test, its own observability stack, and so forth. During here, in evaluators phase, the application gets tested. Here, I especially used the disco ball as its mirrors are very fragmented. You don't have a whole picture around, but fragments of it. So we collect fragments of observability data pretty much from all the components here. It's already there, Open Telemetry. And here the evaluators automatically evaluate. This is the job of the new, instead of trying and testing yourself, you are writing evaluators code so that if the performance values are acceptable and these tests pass and so forth, with the observability data, these evaluators decide, for example, for the merge request, it decided to also put with Argo rollout 10% traffic onto production 10 minutes and also got a sample from that. And accordingly, it gets up to human to move forward with patch towards production, or the patch created a functional problem, performance problem. Then in any case, its results are written to database and another schedule is added and the loop continues. In a nutshell, yes, there are many AI tools that can, at the moment, can push something to your pipeline. And this is a very nice blueprint to both use LLMs and also get onto the new of software engineering. It's a fundamental shift. That's definite. I won't be answering, but putting some of the questions here. Should we do it? Either AlphaEvolve, Google's, or another task managers, they are all around. I don't know. I have some takes I can discuss. The other part is the effect of these agents for open source and cloud native foundation products. They were looking for a lot of new developers, less developers. That's another side. So CNCF actions will be important. Also, as the start of CNCF itself was the Red Hat and Google together made Kubernetes open source. At the moment, will Google make the Alpha agent available not just for research purposes to research institutes, but will they give it to open source developers or cloud native foundation? And also, it's a personal fashion, might be silly question. Okay, we copied the neuroscience. Now we are copying the evolution algorithm. When will these stuff start reproducing? That's also sci-fi wise, what I'm curious about. And just the three takeaways. I think it works to look at these evolutionary problem-solving approaches on our infrastructure, softwares in our life, in a sense. Problem definition is much more important now, what to do instead of how to do. So we need to get some skills. And also the main AI hype is general, consumer face, but I guess we need to look at what Google's and cloud providers, their own development on these technologies. I think it will be a long-term impact than the consumer-faced AI stuff, at least for us. That's all from me. Thanks.